Welcome to PC Gaming Tech Summary. I'm your host, Gamer, and today we look at a sweet spot. Well, if you like the result and the conclusion straight away, here it is, 4.5. Sit right back, have a cup of coffee, and we'll get into it. The reason why we're looking at this data today is in regards to cooling. A lot of people have cooling issues, okay? And that's where my focus has been. Where can we look at maybe finding a sweet spot for gaming, okay? And what can work. Some people may have air coolers on, say, a 12th gen CPU and are not able to get another cooler or don't want to or whatever. So this can apply to what my results show, even though I'm using a liquid AIO. So it's been a little while since I've made a video. I've just made a change in tech. I'm not stressing myself out so much, pushing myself just to crank out videos. And so, you know, my goal is to sort of like one video a week or something like that. If you put suggestions in the comments, then I may be making more than that. So this is a video that's going through the 12700K, the CPU AIO cooler, all-in-one cooler, the Corsair H100i 240 Elite. And it's just phenomenal. As you'll see from my data, it's just, the cooling is just phenomenal. And also, using the 360 12 gigabyte, it is the EVGA XC. So when I bought this last year, February 25th, when it was released, yeah, so it was the cheapest one. It has 2 fans. Now, if I were to do it all over again, I would try and get a card with 3 fans. So if you're going to look at a 360, or even the new 4060s that'll be coming out very soon, I personally am going to look for a 3-fan card. The 2 fans, yeah, it's just a little bit noisy. The fan's a little bit noisy when it's 100% and that kind of thing. I can live with it. I'm used to it. It's not giving me a headache. Definitely more noisy than the CPU Corsair fans. So they've really improved their fans over the years, and you can select different settings. Generally, because I'm doing so much testing, I've got the fans on the extreme setting, so that maximizes the cooling. And you will see from some of the data today that as you go for more powerful fans, it does better in its cooling. And I didn't see that so much on my older system, but I definitely see it on this system. So if you've got a 12900K, a 12600K, something like that, my 12700 is right in between, so you'll definitely be able to pick up some interesting information from this video. Now, my results, I would call them qualitative, okay? So to make them quantitative, I would have to do 3 to 5 runs of everything. I've done so much testing that I haven't had the will to do that. So let's look at these as qualitative. Now, when I felt that they were really important, I would do 3 runs. One thing that I found that I thought was interesting is when I had the CPU at a higher frequency, let's say stock frequency, you know, around the area of the stock frequency, that the FPS values were very consistent. Once I dropped the frequency, down to say 3.6, which is the lowest I believe that I can go, then the numbers were, you know, a couple FPS up or down, so it wasn't as consistent. So I thought that was very interesting. And also, we've got 8 cores, right? These are the performance cores, the P cores. I've got 3 of those cores that I consider hot cores. So sometimes I have them at a lower frequency than the other 5. The efficient cores, there are 4 of those with 1 thread each. The performance cores are 2 threads each. The efficient cores are smaller, like laptop type cores. So one test that I did yesterday that I thought was very interesting was that I put that at 4 gigahertz. I put the 8 P cores at 3.6 gigahertz, just to see the difference between having every single core at 3.6 and then only boosting up those efficient cores. When I do the testing, I want VSync off when I'm looking at FPS. If I'm looking at wattage, then I would look at it sometimes with the VSync on, because with VSync, what that does is it allows your graphics card to take a break, basically. So I've got 4K gaming with a 60 hertz monitor. So the maximum frames per second I need are 60 frames per second. So by turning VSync on, that will limit the FPS to 60. Now, I was playing a bit of Elder Scrolls Online the other day. I had VSync off, and when it was loading a map, it was at 1,200 frames per second. That's just ridiculous. I don't need my graphics card doing that. I need to prevent that, in fact. That's not good. So basically, you come down to your system tray, look for the NVIDIA. Okay, you right click, open up the control panel. Takes a second, comes up. Okay, so under Manage 3D Settings, let's have a look to start with at the VSync. So vertical sync, I've got it on. Okay, and I'm going to do some testing, so I'm going to turn that off. Okay, so to do that, I just come down to the bottom right where it says apply, and we'll just wait for that apply to disappear. Okay, now other thing that I'll show you is up here I have set a maximum frame rate of 600 frames per second. So there is a setting here where you can adjust that. And I have it up that high because of just in case there is some averaging and other things going on with games. So that's why I have it up there. Anyways, okay. Now we're going to look at 4K. So obviously, if you want to change your resolution, you go to change resolution. I've got it set here at 4K, which is 3840 by 2160 native. That's the native resolution, and it is refresh rate. So I tend to actually change the resolution of the monitor when I do my 1080p testing. So I'll come down here and apply that, and then obviously the game do that as well. Well, here we have the benchmark results for Shadow of the Tomb Raider. First of all, we're looking at 1080p and 3.6 gigahertz on all cores, all 12 cores. So 20 threads, 12 cores, 3.6 gigahertz. We get 130 FPS using an average of 59 watts. The temperature of the entire CPU package. The average is 37 degrees C, and room temperature is 18.1 degrees C. All right, so now, as I was saying, what I did here is I took the efficient cores, the 4 efficient cores, and I overclocked them to 4 gigahertz. Left the P cores at 3.6 to see the difference. And what happened is that it used a large amount of power, so 72 watts. And if we look at the difference between these two numbers, it's 20%, between 59 and 72. Now if we jump down here to 4K, similar thing. So we get a FPS of 74, and the watts have gone from 43 to 51, which is a 17% difference. So very interesting, isn't it? So if we compare the amount of watts at 3.6 gigahertz at 1080p is 59. When you go to 4K, you save in power on the CPU. Look at the power being used by the GPU, the graphics card. I've done this sort of calculation in the past, and then so you can get a total amount of watts being used by both the CPU and the GPU and look at those differences. But I thought this was very interesting. It's needing to use a lot more power to overclock those E-cores. So if we look at a difference at 1080p between 3.6 going up to 4 gigahertz on the performance cores, we get a similar amount of watts. So it's taking a similar amount of power to use 3.6 gigahertz as it is 4 gigahertz. If we boost it up to 4.5 gigahertz, then it is 67 watts. The difference between 59 and 67 is 13%. If we look at 5.2 gigahertz overclocked on 5 of the P cores, and 3 of them will be set at 4.5 gigahertz and the E-cores at 3.6. And we put a voltage offset of plus 0.040 volts or 40 millivolts. Okay, so I used that offset to make the CPU more stable and for it to work. And we get similar FPS, 137, compared to the 4.5 gigahertz. And we're using 93 watts on average, okay? The package CPU temperature on average, 53, so that's the highest temp. Yeah, so there's a 32.5% difference between using 67 watts and 93 watts. So basically, if you just looked at this, it would be a very more economical to have it at a lower frequency, especially if you're not getting more performance. There's no point using that much power if you're not getting anything for it. You're just creating more heat and wasting of the energy. All right, so looking at 4K, again, with the 4K results, we're using less power altogether, okay? You know, we're creating fewer frames. Okay, so as I was looking at, there's a 17% difference between using all cores at 3.6 gigahertz and boosting the efficient cores from 3.6 to 4. So that's a very interesting result. Now if we look at 4.0 gigahertz on the P cores, all 8 P cores, and 3.6 on the E cores, we're looking at a similar wattage here, 43, okay, compared to all at 3.6. And we see the same thing up here at 1080p, similar voltage. Okay, so let's move on to 4.5 gigahertz on the 8 P cores, 49, okay. So if we look at the difference between 43 and 49, it's a 13% difference, okay. If we look at 4.2 gigahertz, 5.2 gigahertz on 5 of the P cores, 4.5 gigahertz on 3 of the P cores, and 3.6 gigahertz on all the 4 E cores with the 40 millivolt offset, we're looking at a difference between 49 and 69 watts of 34%. Okay, so just looking at this, 4.5 gigahertz looks like an interesting choice here. And in this particular testing, I didn't do stock voltages, which would be 4.7 gigahertz on the P cores and 3.6 on the E cores. If we look at a difference of 43 watts to 69 watts, that's a difference of 46%. So what I've done is I've went ahead and did the testing on the stock frequencies at 1080p and 4K, and you can see that in the gray colored cells. And at 1080p, I found that there was a 14% difference in power between using 4.7 gigahertz and 4.5 gigahertz. You save a couple of degrees. The 4.5 gigahertz setting is basically a sweet spot for rendering videos. So if you're having a little bit of problem or you wanted to save some more power, that is an option to underclock to 4.5 gigahertz. Now if we look at 4K, we get a similar result. There's a difference of 11.5% between 4.5 gigahertz and 4.7 gigahertz. If we move on to the different settings on the Corsair H100i AIO, I've had some interest in this CPU cooler. We can look at, now I've got just in the green, that's just from using stock settings, and the extreme setting, that's what I get playing Hitman for 3.5 hours at 4K. Now, if we move down to black, pink and black, 0 RPM. So basically that turns the fans off until it reaches a high temperature and then kicks those fans on. So I did it for 27 minutes playing Hitman, and I got a result of 60 degrees C. If I switch to the quiet mode, I improved the temperature by 8 degrees, and the fans do stay on all the time, but they're very low RPM. If I change it to my favorite setting, balanced, then we get a temperature of 49 degrees, and that's using an average of 63 watts on the CPU. Now, if we go to the extreme setting, we get a difference of 3 degrees from balanced, a result of 46 degrees C. So as you can see, running at 5.1 gigahertz, overclock the 12700K, the cooler does a phenomenal job. Well, if you're interested in seeing a few more of these videos, well, all you have to do is subscribe, and you'll get notified when those videos are ready. And thanks for joining us here on PC Gaming Tech Summary, and don't forget, you'll be seeing me in the next video.
No, no, no.